Okay, one second. So, let me just go back for a minute because we're going to do this next problem here. But the question came up, which is a really good question. Why is this the opposite sign? So I meant to say before, when we have this slope formula, the slope formula actually gives us the point slope formula. They're actually just rewrites of the same formula. So we have the slope formula m equals y2 minus y1 over x2 minus x1, and we need 2 points to find the slope, right? But check it out. This is almost like your rational equation. Can I get y by itself? Well, watch what happens. I could multiply both sides by, this relates to our rational equation, doesn't it? x2 minus x1. What happens if I multiply both sides by that? x2 minus x1. These cancel, leaving m times x2 minus x1 equals y2 minus y1. Well, here's the thing. I only need 2 points to find the slope. I don't need the second point in the equation. If I want the equation of the line, so I switch the x2 out. I go m times x minus x1 equals y minus y1. Well, how can I get y by itself? What would you have to do? I could add the y1 to both sides. So I get y equals, I just put that on the other side, m times x minus x1 plus y1. That's the point slope form. So all we did was we took the slope formula, we rearranged it, and we got this point slope form, which is where that negative sign comes from then. Okay? So for this one, I asked you to try it. What was the slope? Yeah, and it's negative, isn't it? So the question came up, which is a great question. Where should the negative sign go? Should it go with the numerator? Should it go with the denominator? Or should it go with both? Either, but not both, right? So you could call it negative 1 over 3 or 1 over negative 3. And that's helpful when it comes to slope, right? Because we're talking about rise over run. So we definitely want to give the negative sign to one of the places, right? And then what is the point? What is the point really? No, what's the point from the equation? Positive 4 and positive 2. And so if we're going to use the point and the slope to graph the line, I'm going to first scale everything. So I'm going to just draw my y-axis. I label it y. I'm going to draw my x-axis. And I'm going to label it x. And then I probably need a few points. So I'll go 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. I actually really like labeling the axes this way. So I feel like it's more spacious. It looks just like has more room. Okay, so now I'm going to, what am I going to start by doing? What did you do first? Yes, I'm going to plot the point 4, 2. So I go over 4, up 2. 4, 2. Not 2, 4, right? Totally different point. All right, and now what do I do with the slope? How do I? Okay, I'm going to rise 1, and that's important. The reason why we have these written in both ways is because there's no room to go forward 3. On my graph, there isn't. I could have drawn it differently. So if I go up 1, I could go back 1, 2, 3. Up 1, back 1, 2, 3. Did I do that right? 1, 2, 3. Yeah. And then 1, 1, 2, 3. And all of those points should form a straight line. Now, if I wasn't sure, because I noticed some of you, well, how do you know? If you graphed it correctly, what is it going to look like? It's going to be a line that's going down. Now, some of you had lines that were going up. And that's very common. When we mess up a lot of times the slope, that's going to be one of the biggest mistakes. Is your line going up or down? So you want to check, is it a negative slope? My line should be going down. But literally, you can take any point Give me the ordered pair from that line that's on that line. 1, 1, 3. You can take any point, and if you plug it in, this is the idea of a checkpoint, okay? And students, for whatever reason, they don't like to check their work. They like to do the work, but they don't like to check to see if it's correct. So the way you would check it is you could take any point from the line. I'm going to grab this point, 1, 3. If I plug it in, it should work out. So I should have 3 equals negative 1/3 times 1 minus 4 plus 2. If that works out, then I know that my line is graphed correctly because I took a checkpoint, okay? So here I have 3 equals negative 1/3 times negative 3 plus 2. What's negative 1/3 times negative 3? 1. 1 plus 2, is that equal to 3? Yes, 3 equals 3, and that is graphed correctly. Oh, I just took the point because here's my xy. I plugged in x, or plugged in y into the equation. I plugged in x. Oops, I plugged in x here. So I just plugged in my x and y back into the original equation to make sure it worked out. A different point. You could use 4 too, but then, you know, that's the point we already knew that we started with, right? Okay, any questions about that?